if you're at main event. Each game requires a token, and each player can earn tickets. Tickets can be traded in for prizes before leaving the arcade. Okay. So we got a first task. Our first task, it says Hayden and Bianca play several different rounds in two machines below. They determine that machine A and machine B are giving them tickets based on different patterns. So what is the first pattern? Let's look at this. Machine A, you put in 9 coins, you get out 36 tickets. Then Bianca put in 6 coins, she got out 24 tickets. So the 6 coins were a value of what?
24.
Oh, okay, so you're saying times 4 for both of them? Is that 9 times 4?
Yeah.
What about this one? Is that about right? Okay, so go ahead and write that because you're looking for a pattern.
You put the X instead of
Oh, I sure did. I'm glad you caught that.
You don't get a pineapple?
I'm going to take a list just so we can move along. Go on. All right, so now times 4 times 4. Did I put the multiplication dot, or you can put it in parentheses, but I think the multiplication dot is better. Okay, so since it's times, what does that give you an idea about? It's multiplicative, yeah. All right, so machine B, 9 coins in, 10 tickets out. 6 coins in, 7 tickets out. What's the pattern? +1, very good. Make that a plus, it looks like a times. All right, so it says, what pattern did you notice for both machines? We already did that one, so you should have put times 4 here. That's a times, and then a plus, oh wait, and a +1. And then, that's a times, it looks weird. So then it says, how many tickets would 8 coins produce in each machine? So how many tickets would 8 coins produce? If, sorry, 32. So, 32. What about this? Oh, what about this one?
9.
Yeah, is it 8 coins? Yeah, because +1 will make it 9, yeah. Y'all got that? So for A, it would be 32. For B, it would be 9. Make that a little legible. Okay, so if Hayden and Bianca got 48 tickets out of machine A, then how many coins did they have to pay?
12.
So we got to work backwards. Why did you say 12?
Because if you divide 48 and 4, you get 12.
Hey, look how I wrote that. 48 divided by 4 equals 12. Remember that fraction bar is always a division symbol, every time. Okay, so now they're asking what equation could be used to represent T, the tickets, how many tickets were given when C, coins were placed in both machine A and B. So let me give y'all some test-taking strategies. When you see how many T tickets, that right there is telling you that's what letter, X or Y. For the what? The X or the Y here? Y. Yeah, you're looking for the answer. Or what other word? What other word? Nope. Nope. Come on, y'all. Well, the answer's a total, but what else? What else? Look at the, look at the, if we talk about Y, that's the answer, the output. I can't believe y'all jumping around like this. You can put total above there, total answer or the output. So when they give you word problems, they're going to say T equals, or they're going to say C equals. That's why I'm trying to put y'all on game. So when you see how many blah, blah, if it's a different letter, immediately you need to be saying, oh, that's a Y. That's the answer. That's the output. Okay? And the C is probably going to be the input. I bet you the C is going to be the input. Okay, so it says how many tickets T were given when coin C were placed in both machine A and B. Okay, so if we write the equation for A, what's the equation going to be? T equals what? T equals 4 times C. Okay? Underneath it, write what the multiplicative equation is that we need to have memorized. What is it? What's the multiplicative equation? What is the multiplicative? What is it? Underneath it, I want you to write the or above it, the multiplicative equation, where you got this T equals 4C. Where'd you get that from? What is the multiplicative relationship equation that lets you know that this is true? That we're supposed to memorize. I want the regular multiplicative equation that y'all are supposed to memorize. Sitting right there.
Y equals A times X.
Yeah. A times X. Thank you.
Go.
I just wonder why, I'm wondering why y'all are not catching this. See, this is the answer and this is the input. This is the multiplier. That's the number that doesn't change. No matter how many, whatever number we input it in, we're always going to multiply it times this 4. Going. Okay, so let's just review this. What pattern did you notice? I think I did all this, so let's go down to D. What equation can be used to represent how many T tickets were given when coin C were placed in both machine A? Coin A was, the Y is the answer, the total answer, or the output, and the Y is the same as the T right here. I really want y'all to remember that if it's a different letter, don't let those letters confuse you. Figure out what your Y is. When they say how many, that's your Y. Okay, and that your input is going to be that other letter, which is the C. And that your multiplier, in this case, since it's multiplicative, is going to be the A. The other one was B, for B coins, is T, tickets equal the coins plus 1. The coins, the C is your input. The 1 is the constant. Y'all write constant by that plus 1. Okay. Constant by that plus 1, C plus 1, because remember the constant, that does not change. That does not change. It's always going to be plus 1 no matter how many coins you put in. And then down here at the bottom, we looked at the different scenarios. We said that this is multiplicative, and we said that this is additive. And then we looked at the different scenarios where Pluto's Playhouse has X total arcade. That total arcade is the Y. And the owner has ordered 7 new games. So that means they added 7 new games. What is the Y? What is Y, the total number? So this is additive. Y equals X plus A. Then we looked at the one below. The cost of the bowling at Pluto's Playhouse is $7.50 for each round. Each means multiply, so that helps us quickly figure out that this is multiplicative. The equation is Y equals A times X. Remember, A is the multiplier, the input is the X, and the Y is the total. And then we did the bags of popcorn cost $2.50. They could have put each on there, but we know it's $2.50 each, where Y, the total, represents the number of X bags of popcorn. That's multiplicative, which would be Y equals A times the X. And then the last one is additive because the number of customers at Pluto's Playhouse is 24. That's telling you what the constant is, okay? Then the number of customers, then X number of customers enter. So what is the total number of customers? So we start with 24 and then we just continue to add. That's additive. Turn the page. Okay, now we're going to look at the tables below to write an equation and determine if each of the tables below represents a multiplicative or an additive relationship. So let's go ahead and write at the top, multiplicative. I know it's a long word. And we're going to write the equation y equals a times x. Okay, and then we're going to put additive. And then we're going to write the equation y equals x plus a. And then we're going to highlight the constants. What are the constants for both of these? What letter? A. Okay, both of these, the constants never change. Write that note to remind yourself. The constants never change. If y'all can remember this, anytime you get these types of questions, and you just take your time and just say, remember, look for your A, look for your Y, look for your X. Now, let's just test this. What did we see for A? Is it times or plus? We're looking for a pattern. How do we get from 2 to 16? What ways can we get from 2 to 16? 8. So, Alea says 8. So let's see if it's times. Let's see if it matches. 2 times 8 is what? 4 times 8? 6 times 8? 8 times 8? 10 times 8? Multiplicative or additive? Multiplicative. Input, output. So we're going to write the equation. What is it? Oh wait, what goes in between? So it's the x times the outlier. It'd be quicker to just do the dots. Oh,
You put 4
out. You caught me. Oh wait, I did this all wrong, didn't I? Lord,
I was gonna say something, but I was like,
I don't know why you didn't say something.
I thought you were gonna do it a different way.
No, I'm here to make mistakes. All right, so this right here is the multiplier. This is my A. That's normally in between there. What is the equation? Y equals what? What is the equation for this table? 8 times x. Once you figure out what the multiplier is, then you just drop that straight into the equation. What's happening here? Can we multiply 4 times 2 to get 8? Can we multiply 6 times 2 to get 10? No. So then let's go back to adding. Can we do 4 plus 4 is 8? What about 6 plus 4 is 10? 8 plus 4 is 12. So what is this? Additive or multiplicative? Additive. This is the input. Go ahead and put, I don't know where I put additive. What did I just put a little A there? We know it's additive. They don't leave enough room. Let's just do the equation. What is the equation? Y equals, this was plus, what do we add? Plus 4? So the equation is y equals, what plus plus? You got you? I want y'all to keep an eye on this. Whenever you figure out your multiplier, that's what you're going to add to the equation. The y and x stay the same. Okay, let's look at this. This is your input. This is your output. Ooh, what do we have here? Oh, we were supposed to write all this down here. I was wondering why we didn't have any room. Y'all don't help me. Y'all don't help me. Y equals 8 times x. No, just bring it down. This is multiplicative. We already know B was y equals x plus 4. That's additive. C is, what are we doing? X to y. Is it going down or up? It's going down by how much? 1. Does it go down by 1 on each of them? Yes, so it'll be y equals x minus 1. And it's additive. If you say, how do I know? Go down by 1. This is time, times 8. This is plus 4. It's not that much to show how you know. D. Ooh, what's happening here? Up or down? Down. Ooh, that's a decimal. I'm gonna skip and go to a whole number. Is it going down by subtracting 5 to get 5? I mean 10 to get subtracting 5 to get 5 from 10? What about 5 from 20 to get 10? So then can I divide 10 by a number to get 5? 2? So what is it? Now, this is where it gets tricky. It's y equals, since we're dividing by 2, or halves, it's 0 and 5/10 x. Put a star by that, because I got to show y'all that, because that's different. I haven't taught y'all fractions and decimals, so I don't know what y'all know. So each x is multiplied by 0.5 tenths. That's what that is, 0.5 tenths. So now listen, when we're done, tomorrow, if you haven't done the task, you're going to do the same thing, but instead you're going to be looking at a graph, and you're going to write out the equation, and then you're going to figure out what the relationship is. And then you'll just do your homework, okay?